We are now in Module 16. So we have already discussed graphing. We have graph circles, and we have graphed some lines. And what we're going to be doing in this module is we're going to be talking about some generic vocabulary words that relate to any type of graph. So these are not just words for lines. These are for any graph we do. So if you would please go to your notes. Let's first look at the words we're going to be talking about today. We have 4 vocabulary words we want to discuss. The first word is relation. And relation is just another word for an ordered pair. And we all know an ordered pair means you have an x value and a y value. You most simply have a point. So the point, -3, 7. We used to call it a point when we were in elementary school. Plot the point. When we got to algebra, we called it an ordered pair because we understood the numbers were in order according to x and y. They were a pair. In college math, we can be more specific and say it's a relation. So you'll hear me say point, ordered pair, relation. They all mean the same thing. Now what's important is because every point has an x value and a y value, they're given special names. The x value is called the domain. So if you look at my point, -3, 7, I would ask, what is the domain? I'm asking, what's the x value? And it would be -3. The other part of a point is the range, which is the y value. So think of range like going high and low is like the y-axis. So if I ask you the range of -3, 7, again, I'm asking you what's the y value, which would be 7. So every point, every ordered pair, every relation has a domain, an x value, and a range, a y value. Now, the last definition is the word function. Mathematically, the definition says a function is a relation in which each value in the domain corresponds to exactly one value in the range. Now that's very wordy. So let's make that make more sense. First, let's take apart the keywords. The keywords in there are relation, domain, and range. We just said a relation is a point. We just said the domain is the x value and the range is the y value. Well, I'm going to make this a real life definition for you. If you know anything about genetics, you know it takes 2 X chromosomes to make a girl. So in math, you can think of domain, the X, as being the girl. In genetics, it takes an X and a Y chromosome to make a boy, a male. So in math, the range, which is the Y, is the boy, the male. So if I take this definition and relate it to you in real life, this is what I would say. To be in a functional relationship, each domain, each girl can date, correspond to only one range, one boy. Now think about that. That makes sense. To be in a functional relationship, every girl can only date one boy. You all agree with that? Sure I do. Here's the problem with that definition. It doesn't say the reverse. It does not say every boy can only date one girl. I know that's very sexist. We could all giggle about that. But think about it. Most mathematicians are men. So this is a man-made definition, ladies. So everybody just understand. The word function means exactly what it sounds like. Every X, every domain can only match one range, one Y. All right, we're going to do several examples with this. The first one is a picture. If you look, I have a picture here, and I have 5 points plotted. We're not connecting the dots. They're not going to make a line. We just have 5 points, 5 relations. With this picture, I can ask you domain, range, and function. So let's go up to the board and do this one together. So I'm asking you 3 things about this picture. I'm asking you its domain, its range, and if it's a function. So first, what does domain mean? Domain means X. Can you give me the X value every point? Sure you can. This point's x value is -2. This point's x value is -1. This point's x value is 1. This point's x value is 2. This point's x value is also 2. So I don't need to write the number 2 twice. And we'd put these in braces because it's holding a set of numbers. So we would say there are 4 x values in our domain. What does range mean? Range means y. Okay? Let's look at each of these points and list its y values. This point's y value is 2. This point's y value is 2. So I don't need to write that again. This point's y value is 3. This point's y value is 3. I don't need to write it again. This point's y value is 1. And if you look, we usually put them in numerical order. So we would say the range is 1, 2, and 3. So far, so good? Good. Here's the killer. Is this picture a function? Function means for every x value, there was only one y value. That means at every x value, there was only 1 point plotted. So at x is -2, there's only 1 point plotted. At x is -1, there's only 1 point plotted. There are no points at x is 0. At x is 1, there's 1 point plotted. But everybody look very closely. At x is 2, there are 2 points plotted. It means this x value, this girl, is dating 2 boys. She's dating y is 1, and she's also dating y is 3. And that can't happen. To be a function, every x value can only have one y value. So you cannot have at x is 2, 2 points. Therefore, this is not a function. Everybody okay with that? All right, great. Who says I have to give you the points with the picture drawn? If we go to our notes and we look at set B, now we don't have the picture drawn, we're just given the points. So look at what you're given in the next example. You're not given the picture. You're given the relation 1, 2, 3, 4, 6, 5, 8, 5. Okay, they're giving you the sets of points. They're not giving the picture, they're giving it to you just listed. If you want, you could draw that out, sure. And I could draw that out in blue. 1, 2 would be here. 3, 4 would be here. 6, 5 would be here. 8, 5 would be here. So I drew those 4 points in blue. The domain just means the x values. Well, I don't need the picture. I could see the x values. 1, 3, 6, 8. The range. I don't need the picture. I could see the range because the range is just the y values. 2, 4, 5. Well, that's another 5. I don't need to write that. Okay, so telling the domain and range is simple. Is it a function? A function means every x value, every girl is only dating one y value, one boy. Well, if you look up here, you could tell. Girl 1 is only dating boy 2. Girl 3 is only dating boy 4. Girl 6 is dating boy 5. Girl 8 is dating boy 5. Now I know what you're thinking. You're saying it's not a function. Yes, it is. Every girl, 1, 3, 6, and 8, each have one boyfriend. If you look at the picture, here's the x value, there's only one blue point. Here's the x value, there's only one blue point. Here's the x value, there's only one blue point. Here's the x value, there's only one blue point. This is a function. Now you're going to say, but the y's we're using twice. Remember, the y's are the range. And we said the definition of function, it doesn't matter what the boys do. You could have a boy double timing a girl and dating more than one. So it doesn't matter about the y's. All it matters to be a function are the x values. So keep that in mind. Now, let's look at the third example. The third example doesn't show a picture and it doesn't show the points. It shows what we call a mapping or a bubble. And the bubble has a 2, and then the other bubble has 4 numbers. Oh, I'm sorry, the bubble has a -2, and then it has a 2, 8, 3, and 1. And the arrow's pointing, and the arrow's pointing. Okay, the first bubble represents the x's, and the second bubble represents the y's. So you could tell me the domain. What's the only x value? -2. You could tell me the range. Well, the y values are 2, 8, 3, and 1. And of course, on paper, we would write that in order. 1, 2, 3, 8. That's easy. Is it a function? Does every x only match up with one y? Well, look, here's the x value, -2. It matches up with 2. That makes a point. Here's the x value, -2. It matches up with 8. Here's the x value, -2. It matches with 3. Here's the x value, -2. It maps with 1. Well, if you look, that x value is matched up with 4 different y values. That can't happen. That girl cannot date 4 different guys. So is this a function? No. Everybody's good with that? All right, let's go back to our notes. Now, if you look at your notes, if I can get them up. There we are. If you look at your notes, now what's different? What's different is I'm not just giving you specific sets of points, I'm giving you a graph. And that's a graph of what? Very good. It's a graph of a diagonal line. Now, how many points do you need to draw a diagonal line? That's right. You need 2 points to draw a diagonal line. But does that mean there's only 2 points on a diagonal line? No. Every speck of ink you see is a point. So I'm going to ask you the same questions about a diagonal line. I'm going to ask you the domain and range function. Let's go to the whiteboard and look at this. Okay. So here's that diagonal line. When I ask you for that diagonal line's domain, I'm asking you for every point's x value. Well, I know you can go pick a point and say, okay, this point's x value is 0. This point's x value is 1. This point's x value is 2. But can you sit here and list me every point on this line? No way. The whole concept is there's arrows on the end because the line goes on forever. There are infinitely many points on this line set. So you can't list me every x value as a number. You can't make a list of them. So what you're going to hear is to give the domain, you're going to have to put this in what we've already learned was called interval form or interval notation. You're going to have to tell me what the smallest x value could be and what the largest x value could be. So now, when you look at the line, we talked about this already. When you look at a line, you read it from left to right. If you look at me, this point's x value is -1. This point's x value is -2. This point's x value is -4. This point's x value is -6. This point's x value is -7. But is that the smallest x value? Well, what does the arrow mean? The arrow means I could keep extending this line. And if I keep extending this line up, it also goes out. So what is the smallest x value? Well, this line's going to go all the way to the left as far as you let it. So you can't give me the smallest x value. You would say that's a concept. You would say it's -infinity. Does that look familiar? When you remember when we shaded all the way to the left on the number lines, we couldn't say it ended. Well, the same thing. If you look at a diagonal line, it's going to go all the way to the left. It's never going to stop. You can't give me its smallest x value. So that's -infinity. When I ask you, what's its largest x value? This line, I don't care about it's going down. It's going all the way to the right. This has an x value of 1. This point's x value is 2, 3, 4, 5. This point's x value is 6. This point's x value is 7. We can keep going. So this line's going to go all the way to the right, and that's going to take us to positive infinity. So when you talk about domain, you talk about going from the left side of the graph to the right side. How far to the left does the line go? All the way. How far to the right does it go? And if you remember when we did interval notation, infinity always goes in parentheses. Now we're going to do the range. Range means the y values. Well, the y values are going up and down like the y-axis. So when I ask you the range, again, you cannot sit here and take every point and list the number it has for y. You can't do that. There's too many points on a line. They're infinite. So what you're going to tell me is the lowest y value, how low to how high. And the reason why we go low to high is, remember, when you do interval notation, you do the smaller number and then the bigger number. So again, how low does this line go? This point has an x value and a y value in -1. This point has a y value in -2, -3, -4, and so on. It's going to keep going down, 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 down. It's going to go as low as it wants. So its range starts at negative infinity. You can't tell me how low that line's going to go. It's going to keep going. The same way, how high is this line going to go? This point's y value is 1. This point's y value is 2. This point's y value is 3. And so on, and so on, and so on. The higher up this line goes, the bigger the y values get. So we would say it's going to positive infinity. Now, if you're one of these people that like to memorize facts, then you might as well memorize that. The domain and range of a diagonal line are negative infinity to positive infinity, because a diagonal line goes left to right as far as it wants, and it goes up and down as far as it wants. It covers all the numbers. Is it a function? Well, this is what's different. To tell if it's a function, you have to know if every x value matches with one y value. Well, you can look at the picture and say, okay, here's x is 1, there's 1 point. Here's x is 2, there's 1 point. Here's x is 3, is 1 point. But they came up with even a better way. It's called the vertical line test. And it says, anywhere on your picture, draw a vertical line. If your vertical line touches the graph in one place, it's a function. Now, everybody look. The graph is the line in blue. Where does my vertical line touch? It touches in one place. That means that this is a function, because for this x value, there's only 1 point. So that's called the vertical line test. Okay, let's look at another picture. Let's go to our notes. The next picture is not a line. So let me get it up here for you. All right. My eraser's not working that great. All right. If you look at the next picture, it's a curve. It's a wave. It's okay. You may never have to learn how to graph that wave, but we could still ask the 3 questions. So let me get some information up here to get it graphed. All right. And then we got a point at, I'm looking to see where the points are at. -1. And the other point is at 5. All right, so I'm going to do the best I can with drawing it, but it looks something like this. Okay, something like that. It's a curve. It doesn't matter what graph I give you, you can always answer the 3 questions: domain, range, and function. Again, because there are infinitely many points on here, if I ask you for the domain, you just can't list all the x numbers. So what you're going to do is you're going to give me where they're in between. Okay? On this graph, there are arrows on the end. I think they got cut off, but they should be there. Okay? So again, when I ask you domain, I mean, how far to the left does the graph go? How far to the right does the graph go? Well, if you look at the graph, it's going to go to the left, and you may think it stops, but that arrow means it's going to keep going. So if it keeps going to the left, what concept is that? Negative infinity. Again, how far to the right does it go? Well, if you trace it with your finger, there's going to be an arrow here. which means it's going to keep going to the right, which is positive infinity. So the domain of that curve is negative infinity to positive infinity. Now range is your y values. Y means low to high. Now, there is a low point on this curve. Do you see any of the curve here where y is -2 or -3 or -4? No. The lowest points on the curve are right here, and their y value is at -1. So we have a low point, -1. And because that's actual point, remember we put the bracket to mean it equals, the lowest y value is -1. Does this curve have a high point? Sure it does. If you look carefully, the high point's right here. What is this point's y value? +1. And because there's a point there, you put a bracket. So that curve is not going to go all the way down low and all the way up. It's got a low point at -1 on the y-axis and a high point of +1. And all the other points are in between there, sandwiched. Is it a function? Well, again, we just said if you have a graph, a picture, you draw a vertical line anywhere on the graph. Don't draw it out here where it's not touching the graph. Draw it there. It touches in one spot only, the blue, the graph. This would be a function. Every x has one y. You with me? All right, let's try another one. Our last picture. Okay, let me erase the curve. The last picture is something you already graphed this semester. It is a vertical line. So it's a vertical line at -3. I'm going to graph it right here. Any graph can ask the same 3 questions, domain, range, function, because any graph is just a set of points, a relation. All right. So, again, if I ask you the domain, what does domain mean? It means x values. Well, if I look at this line is nowhere over here where the x values are positive numbers. This line is nowhere over here where these x values are negative. This line is at one x value only, and the x value is the number -3. Every point on this line has an x value in -3. So we would just write, that's the domain. It's one number. We can list that because it's one number. Now the range is different. The range is low to high. Every single point here gets lower and lower. This point's y value is -1, then -2, then -3, -4, -5, -6, -7. How low are those y values going to go? They're going to go to -infinity. How high is this graph going to go? Well, it's going to go to +infinity. So there's no stopping how low or how high the y numbers are. So that's why we give it an interval notation. Now, is this a function? For every x value, do you only have one y value? Or if you do the vertical line test, does the vertical line touch the graph in one place? You're not going to draw the vertical line here because it's got to touch the graph. Well, the only way to draw a vertical line is to draw it on top of the vertical line. And if you draw the vertical lines on top of each other, they don't intersect in one place, they intersect in many places. So it intersects here, it intersects here, here, here. Which means for every x value, there are more than one y value. So this is not a function. So what we talked about today is pretty much 4 vocabulary words. Okay? The 4 vocabulary words are domain, range, function, and relation. Relation is just meaning points. It could be one point or many points. Domain is the x values. Range is the y values. The function is the hard part. Function means for every x value, for every different x value, there's only one y value that matches up with it. This is clearly not a function because at x is -3, you have a y value of 1, a y value of 2, a y value of 3, and that's not what a function is. Every girl can only date one boy to be a function. Okay, we have one more part of this module. I'll see you later.